Alright, the next concept, solving equations with variables on both sides. You must watch and listen to the video because I am going to incorporate something that you don't want to share with anybody, but it'll be definitely worth your while to watch and listen. Okay, so you have solving equations with variables on both sides. You have your paper set up, so pause the video if you need to get your paper set up. Just don't sit here and watch me because you're going to be doing it with me. All right, variables on both sides. Your name and hour. People are turning in papers without any name, and I can't give you credit if I don't know who did it. All right, problem, checking. You're going to check right beside it. All right, here we have variables on both sides. What you're saying here is 6 times a number plus 7 equals 13 plus 7 times that same number. So we've got to figure out what that number is. Here's the problem though. Some people just want to sit here and guess and check and plug in numbers. Well, you're taking too long. Second, they're not always going to be whole numbers. So you've got to learn some of the procedure. I know it's very procedural. I know it might be boring, but I guarantee you can work any problem if you know your steps. All right, we have variables on both sides. You can really do this next problem 4 different ways. I can move the 6r to that side. I can move the 7 to that side. I can move the 13 to this side. I can move the 7r to this side. The thing is, I like to move the variable terms first, and I like to move the one that's still going to keep the variable term positive. So for example, I'm going to look at 6r and 7r. To get rid of the 6r, I have to do the opposite of what the sign is. Well, that's a positive 6r, so I need to subtract it. Well, if I subtract a 6r from a positive 7r, I get a positive r. So I like that. If I subtracted the 7r, like that's a positive 7r, if I subtracted a 7r and subtracted 7r here, I would get a negative r, which mathematically that's okay. But if I don't have to have my variables negative, I'd rather not. So I'm going to move my 6r. At this time, would you please put a little heart by number 1 so I can tell you're really listening? Put a heart by number 1. Just draw a heart. Okay, so 6r minus 6r is gone. You have 7 equals 13. Now, positive 7r minus 6r is a positive 1r, or just positive r. Subtract 13, because here's the deal. You move your variables one way, you got to move your constants the other. They got to get to the other side. So you can move your variables to the right and your constants to the left, or vice versa. Now watch this though. 7 minus 13 is the reason negative, because you have a positive 13, we're going to subtract 13 to make that 0. 7 minus 13 is a negative 6 equals r. Okay, now checking. I would check after each one. Don't solve them all and then check, because if you're making a mistake, you're going to have to redo everything. So negative 6 goes in for every single time you see the r. So 6 times a negative 6 plus 7, you're testing to see if that would equal the same thing. Here's where all of your struggle with checking is going to pay off. We have no idea what each of these are supposed to equal until the very end. So we're going to work one side and then the other. 6 times a negative 6 is a negative 36 plus 7. Working down, negative 36 plus 7 is a negative 29. Over here, you have addition and you have multiplication. You're going to multiply first. You have 13. Now 7 times a negative 6 is a negative 42. So now I have to do 13 minus 42. Well, that's a positive 13 and that's a negative 42. So I know my answer is going to be negative, but let's figure out if it's really 29. I'm going to do 42 minus 13. You can just switch the numbers and subtract. 42 minus 13, that's 9, that's 3, that is 29, negative 29. If these two numbers do not match, something is wrong, either in your checking or your solution is wrong. Okay? Okay, let's do a second one. Negative 7x minus 3x plus 2 equals negative 8x minus 8. Pause if I'm going too fast. Pause the video. Okay, now look here. You have a combination of like terms that you can do. Always simplify everything first. If it's distributed property, distribute. If it's combining like terms, combine before you move any variable. So this is a negative 7 minus 3. Negative 7 minus 3 is a negative 10x. Bring down everything else. Negative 8x minus 8. Now if I had some other stuff to simplify here, I'd do that on the same line. If I had distributed property, if I had combining like terms, I would do that too, but right now there's nothing that I have to simplify. Now you have variables on both sides. So I got to decide, do I want to move the negative 10x or do I want to move the negative 8x? Well, I could see ahead that if I add 10x and I add 10x here, that's going to be positive. If I add 8x, I'll still have a negative 2x, which is okay, but I just wanted to make sure. I'd like to keep it positive if possible. So I'm going to add 10x, add 10x. That goes away, so I have 2 equals 2x, minus 8. I move the variables to the right. That means I'm going to move the constants to the left. So I'm going to add 8, and get 10 equals 2x. Divide by 2. 5 should be my solution, but I'm going to test it. Always test it back into this original problem. Okay, test it back into this original problem. Would you right here write the word high? Tell me a little high right now. H-I, high, just so I know you're still with me. Negative 7 times 5 minus 3 times 5 plus 2. Does that equal negative 8 times 5 minus 8? We don't know yet, so we're going to work each thing. Now, order of operations here. Negative 7 times 5 is a negative 35. Negative 3 times 5 is a negative 15 plus 2. Work down. This is why I kept saying work down, because here's the huge part. You have to work down, and this side work down. So let's finish this. Negative 35 minus 15. These are both negative, so add them, add the numbers, and take the sign. 35 plus 15 is going to be 50, and negative 50 plus 2. Negative 50 plus 2 is a negative 48. This is going to be a negative 40 minus 8. This is a negative 48, and you can just go ahead and bring that straight down. Every line should have something on the left and something on the right. Don't leave it hanging up here. People forget it, so bring it down so your eyes don't have to go all the way up, just the previous line. Now, this is a true statement. That means 5 is our solution. Okay, I want you to pause this. Pause the video now. You finish 3, 4, 5, and 6. Okay? Pause it because I want you to come back to number 7. There's something about these problems that tricks people up. So pause it, finish those, and then come back to number 7. Okay, you've paused it. We are now at number 7. And at this time, I would like for you, if you're in the classroom, I'd like for you to go by my desk. There is a green box that has candy in it. I would like for you to go grab a piece of candy, just one. Go grab it, enjoy it as you watch this video. Don't let anybody else know where you got it, and you are only getting it because you're really watching the video. So there is a green box. I will tell you, it's not on my desk, but it is on the cabinet, and you may reach in and get a piece of candy, throw your trash away. Okay, so here's number 7. 5 plus 2x equals 2x plus 6. Okay, same thing, variables on both sides, but let's look at this. We're adding 5 to 2 times the number equals 2 times that number, adding 6. Well, if we combine the variables, we got to subtract a 2x and 2x. That goes away, so we get left with 5. Wait, 2x minus 2x is 0, so we have 6. Does 5 equal 6? That's a false statement. So our answer is no solution. There is no number that you can multiply a 2 by and add 5 to one side, but you multiply that same number by 2 and you add 6 to the other side. There's no way those are ever going to be equal. So that is a no solution. The way you check a no solution is you write in A. Do not leave that blank, because I don't know if you just forgot to check it, but write in A because you cannot check a no solution. Okay? Let's look at number 8. I promise you're going to be ready to keep going. So number 8 says negative 4 times 8x. Oh, a negative. Oh, sorry. Better watch what you're writing. 4 times a negative 8x plus 5 equals a negative 32x plus 20. All right, so what we want to do here is we're going to go ahead and distribute that 4 to both terms. So I'm going to do 4 times a negative 8, that's a negative 32x, and then 4 times a positive 5, that's a positive 20. And then I bring everything else down, negative 32x plus positive 20. Oh, you might see something right here. If not, I'll show you how you can see it later. Notice you have a negative 32x plus 20, negative 32x plus 20. They're exactly the same. When they're exactly the same, you can pick any single number, any number. Positive, negative, fraction, decimal, doesn't matter. Pick any number, pi for all you want. Multiply by negative 32, add 20, You do it to one side, you do the same thing to the other, you're always going to get equal. So sometimes people don't see that though, and they have to do this. Sometimes they have to end up moving the variables, and these cancel out, so you get 20 equals, well, negative 32x plus 32x is 0 equals 20. Is that a true statement? That is a true statement. A true statement has this answer. Infinitely, oh my gosh, many solutions. Infinitely many solutions. You're also going to probably see all numbers or all real numbers, or identity. You might see those three answers for this. Right now, Math 8, you'll probably see infinitely many solutions. But if you ever see all real numbers next year, that's what that means. Every number that you know and that you can think of will fit there. And identity. Identity means it's identical from one side to the other. But when you get a problem like this, if it looks identical, signs and everything, signs, numbers, variables, and the constants are the same, it's going to be infinitely many solutions. Okay, to check it, again, put NA. The reason being is because you can put any number in and it's going to be true. But don't leave the checking blank. Put NA so I know you didn't forget. Okay, so at this time, thank you for watching all this. I can't wait to see how you finish up 9, 10, 11, and 12. By the time you're done, you're going to be able to create your own no solution. So good job with that. All right, you may go ahead and work.